So the enthalpy change or energy change calculation exercise, like this whole exercise have questions in which you will calculate the bond breaking energy, bond forming, and then overall energy change. So the first question, a chlorine react with ethane to produce So chlorine react with ethane to produce chloroethane and a hydrogen chloride. The reaction is exothermic. So as I mentioned, the reaction is exothermic. And what is the energy change or enthalpy change? First thing, because this reaction is exothermic reaction, the energy change must be negative. So if energy change is negative, so it cannot be C or D. It is impossible. Because C and D are positive energy change, and positive energy change is for endothermic reactions. So how to work out the bond energies are given to you. So bond energies are given to us. We'll just substitute the reactant side is a bond breaking side, and the product side is a bond forming. First, we identify how many bonds are formed. First, for CH1, 2, 3, 4, 5, 6. So here I'm writing the bond breaking side. First, the bond breaking side. So there are 6 CH bonds, carbon and hydrogen bonds. Then there is one carbon and chlorine bond. Sorry, carbon and carbon bond, not carbon chlorine, carbon bond. And then there is one chlorine bond, Cl bond. We just substitute the values and add them to get the bond breaking energy. Like this will be 6 multiplied by the carbon hydrogen bond is 410. So 6 into 410, and carbon bond energy is 350 as it is given here, and chlorine bond energy is 240. So what's the final answer for the bond breaking? When you 410, it's 410. This is not 401, by mistake I write here 3050. Okay, this is 410. So this is 3050 is a bond breaking energy. So 3050 is a bond breaking energy. Then we'll find the bond forming energy. How to work out the bond forming energy? One, we have 1, 2, 3, 4, 5 CH bonds are there. So for bond forming, there are 5 CH bonds. Then there is carbon bond is there. Then we have carbon chlorine bond is there. And then we have a hydrogen chloride bond, HCl. So we'll substitute the values. So for carbon and hydrogen bond, so it will be 5 multiplied by 410. For carbon bond energy, it is 350. For carbon chlorine bond energy, carbon chlorine is here 340. And for hydrogen and chlorine bond energy, 430. So what's the answer for this? The total bond forming energy? 3170. How to work out the energy change for a chemical reaction or enthalpy change? So energy change or enthalpy change is a bond breaking energy minus bond forming energy. So this much energy is absorbed, this much energy is released. How much is the difference between them? So bond breaking is 350. 90? Okay, 3190. No, it won't match with any result otherwise, if it is 3100. And the bond forming energy is 3170. So when we substitute, we get minus 120. So what's the right answer? The correct answer for this one is B. Bond breaking minus bond forming will give us energy change. Is it clear discussion? Anyone having a doubt? So about in this exercise, like 18 MCQs are there. We'll do like 9 to 8 MCQs and then we'll move to structured questions. Because some questions you have to solve. A similar question is there, ethene react with a hydrogen to form a ethane and the bond energies are shown. What is the energy change for this reaction? But in this case, they did not mention whether this reaction is exothermic or endothermic. So all possible answers are there. Now, how we can work out the reactant side is a bond breaking side and the product side is a bond forming. The bond energies are given to you. You will use these values to work out. First, we have 1, 2, 3, 4. So we work out the bond breaking side. So there will be 4 carbon hydrogen bonds. Then we have carbon carbon double bond, only one of them. Then we have hydrogen hydrogen single bond is there. We substitute the values. So this will be 4 multiplied by carbon hydrogen bond energy is 410. Carbon carbon double bond is 614. And the hydrogen hydrogen bond energy is 436. What's the sum here? So 2690. This is a bond breaking side. So reactant side is a bond breaking. Now a product side is a bond forming side. So we have 1, 2, 3, 4, 5, and 6. So the bond forming side, CH bonds are there, and how many of them? 6 of them. And then there is a carbon carbon single bond in there. Carbon carbon single bond. So we substitute the values. So it will be 6 multiplied by CH, which is 410. And carbon carbon, only one bond is there, 350. When you sum, what's the answer? 2810. Okay. 2810. That's a bond forming. Now, how to work out the energy change? What's the formula for energy change? Energy change is the bond breaking energy minus the bond forming energy. So energy needed to break the bond was how much? 2690. And energy released when the bonds are formed, 2810. What's the energy change here? Bond breaking is 2690. It's bond breaking minus bond forming. Minus 120. So it is minus 120. So if it is minus 120, so B should be the right answer. Is it clear discussion? How we know carbon carbon energy? It's given here. This table about the bond energy will be given in exam to you. So you don't have to memorize them. You can, it won't make difference. You can add them, like example, carbon, hydrogen. There are 6 bonds, so you add 6 times or you multiply by 6. It's the same thing. It does not make difference. 6 times you add the same number, it's same as I multiply by 6. No, there's no relation. Like if a carbon-carbon double bond is 614 and carbon-carbon single bond, it should not be half of it. Like it should not be 307. No, you cannot relate them here. So the bond energies will be given to you. You will use the bond energies to work out the energy change. Now, in this question, methane burned. Look, if something is burning, we did like what is like whenever you burn something, combustion. Combustion is what? Exo or endo? Exo. Combustion cannot be endothermic. So means it cannot be A, it cannot be B as well. So combustion cannot be endothermic. Combustion is always exothermic. So it cannot be A or B because A and B energy changes are endothermic energy changes because positive. Now, another thing for this question, structure is not given. For a question in which the structure is not given, you already have the concept of a bonding. Then you have to draw the structure by yourself. Like in CH4, carbon and CH4 means carbon and hydrogen bonded with each other. And there's a single bond. Why single bond? Because there's a pair of electron between carbon and hydrogen. O2 means oxygen, two oxygen molecules, two oxygen atoms bonded with each other. But what kind of bond they will have? They will have oxygen-oxygen double bond. Why double bond? Because oxygen belongs to group 6 and group 6 elements share 2 electrons. That's why if 2 atoms of a group 6 are there, they will share 2 electrons, so there will be a double bond. And how many oxygen molecules are there? 2 of them. So you have to draw 2 of them. For carbon dioxide, carbon bonded with 2 oxygen. So what is the structure of a carbon dioxide? Carbon into oxygen, but each oxygen share 2 electrons. So carbon will share 2 from that side. So there will be a double bond between carbon and oxygen. And water molecule H2O, 2 hydrogen and 1 oxygen. Each hydrogen share 1, so oxygen share 1. So there will be 2 bonds between oxygen and hydrogen. This is the structure of water molecule. And why? Because 2 molecules are there, that's why I draw them twice. So some questions are easy in which the structures are given to you directly, you will get the answer. But for some questions, structure may not be given. You have to draw first the structure, identify the number of the bonds, and then using the bonds, you will work out the bond energy, and from the bond energy, identify whether it's an endo or exothermic reaction. So reactant side is a bond breaking side. The product side is a bond forming side. So we have 1, 2, 3, 4 CH bonds are there. And we have 2 oxygen double bonded with oxygen bonds are there. This is a bond breaking. So this will be 4 multiplied by CH, carbon, hydrogen, 410, plus 2 multiplied by oxygen, oxygen, double bond, 496. What's the answer for the bond breaking? 4 into 410 plus 2 into 496. 2000? 2630. 32, okay. So 2632. That's a bond breaking. Then bond forming, how to work out the bond forming? So there is 1, 2, like oxygen, carbon and oxygen bonds are there, and how many of them? 2 of them. So we multiply by 2. 496. For oxygen, oxygen it is 496. Plus hydrogen, oxygen or oxygen, hydrogen, how many bonds are there? 1, 2, 3, 4. So this will be 4 multiplied by OH or HO. It won't make difference. You can write any one of them first. So this will be 2 into OC. It will be 805 plus 4 into OH, which is 460. What's the answer for bond forming? The final answer. 2 into 805 plus 4 into 410. Sorry, 460. This 460. 2 into 805 plus 5090. Huh? No, it cannot be 5000 because it's like 4 into 460 plus 8 into 2 into 805. What's a bond forming energy? 4 into 460 plus 2 into 805. 3450. Now, because the bond forming energy is more, so it is obvious that this reaction will be exothermic. If a reaction is exothermic, negative enthalpy change will be there. But how we can work out the enthalpy change or energy change? The energy change can be calculated by using a bond breaking minus bond. So bond breaking is 2632 minus bond forming is 3450. What's the answer?
Yes.
Minus 818. So negative. So D will be the right answer. So whenever a chemical reacts, sometime you have the equation. From the equation, what you have to do? You have to draw the structure first. And from the structure, what you have to do? You have to identify how many bonds are there. Reactant side, it will be the bond breaking side. The product side will be a bond forming side. And then to get the energy change, it will be a bond breaking minus bond forming. Is it clear? This question 3? Anyone having a doubt or a question in this? So in this question, again, you have an exothermic reaction. So either A, C and D are totally wrong. So either A can be an answer or B can be an answer. Then H2O2, the structure of H2O2 is given to you. If any different substance is there, that structure will be given to you. So the structure of H2O2, which is a hydrogen peroxide, is HOOH. And there are two molecules, so H, because you can see here two molecules, HOONH. So bond breaking, how many bonds are there? HO, like one, like this, 1, 2, 3, 4, 4 identical. So 4 HO or OH bonds are there. And oxygen bonded with another oxygen. How many of them? 2 of them. So this will be multiplied by 2. This is the bond breaking site. And bond forming site, H2O, we just drew the structure of H2O in the previous water molecule H2O. And 2 molecules are there, so it will be HONH. And O2 means oxygen, so there will be like this. So it will be HO or OH, and how many? 1, 2, 3, 4. So multiply by 4 plus oxygen double bond is there. You just have to substitute the values. So you have to substitute the values, the bond breaking, 4 into OH. When you solve, you should get B as the right answer. So 460 plus 2 into 150, that will give the bond breaking. 4 into HO or OH is 460, and oxygen double bond 496. So when you simplify bond breaking and bond forming, you will get B as the right answer for this. So first find the bond breaking energy, then the bond forming, and then energy change is bond breaking minus bond forming. If any other substance is there